Welcome back, everyone, once again to Science from Home. I'm your host, Librarian Molly with Spokane County Library District. Today's topic is electricity. And guess what? Fun fact, electricity is another form of our favorite topic, which is energy. Electricity is electrical energy. We're going to take a look at current electricity today, which means the electrons that make up our electrical energy are moving on a path. For today's experiment, you'll need some semi-basic materials. So my dad happens to be an electrical engineer, so we have lots of fun things in our house that relate to electricity. So some of these items hopefully are common, but they might not be. So you need some big batteries. I have two C-sized batteries here, and you need pretty big batteries to light up a tiny LED light. You need some aluminum foil. We're gonna need some tape. Okay, so as you can see, I have all the materials laid out here. The first thing we need to do is create a circuit for the electricity to flow through. A circuit is another name for a pathway. To do this, we need to start with a power source. Of these limited supplies, which do you think is the power source? If you guessed the batteries, you would be correct. So we need to start with the batteries. If you're doing this at home, to get enough power to light even a small LED, you're gonna have to tape two C batteries together on top of each other. So you would put the bump against the non-bump on your batteries, and you want them to stay pretty tight, so you would tape it. I am going to use this handy machine thing that my dad had. So I'm gonna put my batteries in. Here we go. And I'm gonna close it up. Okay, so I've got my power source. A circuit is essentially a circle or a loop. The electrical current is going to leave our power source, and it can travel through things, but the pathway needs to return to the power source. So when we're using electrical energy, we need to start and end in the same place, which in this case is with the batteries. Next, we need to rearrange some of the rest of the materials in a way that they can form a complete circle or circuit, but also includes our light bulb. I'm gonna be using these wires here, but if you're doing this at home, you're gonna need some aluminum foil for this part. And if you are following along at home, this is a great place to pause the video to see if you can figure out how to do it before I reveal the solution. All right, so let's see if I can create a circuit that will light up the light bulb. Oh, there it goes. All right. Okay, so here I have it set up with my batteries taped together, and then using the aluminum foil to create the circuit, I can light the light. So what happened here? To form a circuit, we needed to create a pathway that was a circle. We started with our power source because we need the electrons that light our bulb to come from our power source. You'll see here that in this stack, in the battery has a plus side, which is the side with the knob, and a minus side, which is the opposite side. So I've stacked my batteries on top of each other. It goes plus side, plus side of the second battery, minus side of the second battery. So the electrons are going to exit our power source, the battery, on the plus side of the battery because there is higher potential energy here. We use the aluminum foil to conduct or move the electrons from the battery up to our light bulb. Here at the light bulb, they do work, they light the bulb, and then because we have to end where we began, we use the other piece of aluminum foil to bring the energy back to our battery, but this time on the minus side of the battery, the side that doesn't have the knob. Because we need the electrons to return, and the minus side is the depleted side or the low potential energy side of our battery. Basically, the electrons are trying to go from higher voltage to lower voltage to even things out. So they go from plus to minus, and along the way, we use them to light our light bulb. You might notice that I have my light bulb here is labeled. So my light bulb itself has a plus side, just like the battery, and a minus side, just like the battery. And so when I build my circuit, if your circuit did not work, you might want to flip your light bulb over because you need the plus side of your light bulb to match with the plus side of your power source, and the minus side of your light bulb to match with the minus side of your power source. So in my contraption here, you can see these are also labeled. I know which wire is plus and I know which wire is minus. So I can make sure that when the energy leaves the plus side where there's higher potential energy, it goes into the light bulb the right way. Well, I do hope that you enjoyed this edition of Science from Home and learned a little bit about electricity and electrical energy as well as circuits. Thank you so much. We'll see you next time.